Hello friends, welcome to our Lean Six Sigma Green Belt course. In this lecture, we will understand what is 6 in Six Sigma and what is sigma in Six Sigma. So stay tuned. Sigma in Six Sigma is nothing but standard deviation. It is denoted by this symbol, sigma, and is known as sigma or standard deviation. Now, I am sure you will have a question. What is the standard deviation? Let's understand standard deviation with the help of an example. Suppose, you travel to the office in your own car. You may take 3 minutes, 5 minutes, or 10 minutes at times, to reach your office depending on factors like, traffic on road. Let's say we record the time taken by you to reach the office for 4 days. On the first day you took 5 minutes, the second day you took 7 minutes, the third day you took 3 minutes, and the fourth day you took 7 minutes. Now, let's understand the method to calculate the standard deviation. First, we calculate the average time taken by you to reach the office. We add all values, which in this case is equal to 5 plus 7, plus 3, plus 7, and it is equal to 22. The count is 4. Therefore, the mean or average is equal to 22 divided by 4, which is equal to 5.5. Hence the average time you take to reach the office is 5.5 minutes. Now, let's calculate the variance. The variance is determined by subtracting the mean value from each data point, resulting in minus 0.5, 1.5, minus 2.5, and 1.5. Each of those values is then squared, resulting in 0.25, 2.25, 6.25, and 2.25. The square values are then added together, giving a total of 11, which is then divided by the value of n-1, which is 3, resulting in a variance of approximately 3.67. We divided the sum of squared deviation from mean by 3 because we are considering this data set to be a sample. If you consider this as a population, then you divide it by n, which is 4 in this case. Now, we have the variance. The square root of the variance is known as standard deviation or sigma. In this example, the square root of 3.67 is 1.91, which is the standard deviation. Let's understand the standard deviation or sigma value graphically. Let's consider that the time taken to reach the office is plotted on this number line. On the first day you took 5 minutes, the second day you took 7 minutes, the third day you took 3 minutes, and the fourth day you took 7 minutes. The mean of this is 22 divided by 4, which is 5.5. Now we find the deviation of each point from the mean value. If you subtract the mean 5.5 from 5, you get minus 0.5. The negative sign represents that the value lies on the left side of the mean. If you subtract the mean from 7, you get a positive 1.5, which means it is on the right side of the mean. Similarly, we find the distance of all other values from the mean value. In bigger data sets, we will have a lot of positive and negative values, which when added will result in a very small value almost equal to 0. This was the problem, and hence statisticians decided to square each deviation and then add the squared values. Squaring a negative number makes it positive, and hence the sum of this will never add up to 0. Now we will be able to measure the variance of an individual value from the mean. In order to do that, we find the average of squared values from the mean, which in this case is 3.67. In this example, the unit of variance is square minutes, which doesn't make any sense. Hence, statisticians decided to define one more term, which is standard deviation, which is nothing but the square root of variance. In this example, the standard deviation is a square root of 3.67, which is equal to 1.91 minutes. Now, let's mark these deviations on the number line. 1 standard deviation away from the mean means 1.91 minutes away from the mean on both sides of the mean value. 2 standard deviations away from the mean means 2 multiplied by 1.91 minutes away from the mean on both sides of the mean value. Similarly, we can draw lines at 3 standard deviations away from the mean, then at 4, 5, and 6 standard deviations away from the mean. This 6 here is called the sigma capability. These positive and negative numbers, 1, 2, 3, 4, 5, and 6 are also called z-scores, if we consider it to be a standard normal distribution, while sigma itself is the standard deviation. We will understand the standard normal distribution in detail in our upcoming lectures. Let's say you travel to the office by bus. You want to reach the bus stop anytime between 7 a.m. to 8 a.m. That means your lower tolerance limit is 7 a.m. and your upper tolerance limit is 8 a.m. Let's take 2 scenarios. Scenario A and Scenario B. In the first scenario, we consider the standard deviation to be 5 minutes, and in the second we consider it to be 10 minutes. Consider the mean to be 7:30 a.m. The probability distribution is given for both scenarios. In the first scenario, let's draw a line that is 1 standard deviation away from 7:30 a.m., which means 5 minutes away from 7:30 a.m. We will draw a line at 7:35 a.m. How many such lines can be drawn till 8 a.m.? The answer is 6. First at 7:35 a.m., second at 7:40 a.m., third at 7:45 a.m., fourth at 7:50 a.m., fifth at 7:55 a.m., and sixth at 8 a.m. Similarly, we can pack 6 lines between 7 a.m. and 7:30 a.m. In scenario B, we can clearly see that we can only pack 3 standard deviations on both sides of the mean. This 6 in the first scenario and 3 in the second scenario is what is known as sigma capability. A 6 sigma process is more efficient because the chances of the bus arriving before 7 a.m. and after 8 a.m. is very remote, which means it is almost never going to happen. However, in a 3 sigma process, it is quite likely that the bus will arrive before 7 a.m. or after 8 a.m. That is it for today. Thank you for watching our lecture. Have a wonderful day.